Right. Chapter 5, Lesson 3, Probability of Compound Events. Give you a minute to write some of this down, and then we'll get started. Messed with my sound settings. Hopefully you can hear me. If not, you'll be okay. This is an easy one today. Right. Like we're up, ready to go. So compound event, singular, consists of two or more simple events, and then your sample space. Sample space is a list of all possible outcomes. What we're going to be looking at is just taking, instead of just one simple event, looking at multiple at the same time and see how that changes what our outcomes could be. Okay. Only two examples. They both involve writing. Sorry. So example 1 says, at lunchtime, you can choose either apples or pretzels as your snack, and then you can also choose your drink. You get to pick, what was it, milk, water, or orange juice. So we want to know, what is the probability of someone picking both pretzels and orange juice, assuming that there is an equal chance of picking any of those options. You're welcome, Lauren Anchor. I'm here to help. What's the essential question? Oh, the essential question was, same as it's been, how can we use probability to predict the future? Alright. So what we want to do is we want to make our sample space. So what we do, we take our first event. So our first event was snack. And we say, what are our options when we make our snack? Or we pick our snack. We're not making it. Getting it at lunch. So we can choose either apples. And leave yourself some space here. Apples. Then skip a couple more lines down. And pretzels. There's two outcomes for our snacks. But then we also have to consider our second event, which is we have to pick our drink. If you don't see the essential question, you gotta like rewind a little bit. Okay, so if we picked apples as our snack, what could we pick as our drink? Well, we could pick milk, or we could pick water, or we could pick orange juice. Well, then skip it and you can come back to it at the end. It'll be okay. Alright, what if we picked pretzels as our snack? Does that change what we pick as our drink? And the answer is no. So we could still get milk, or we could get water, or we could get orange juice. And this is the full list. This is every possible way that you can put together your lunch given the options provided. So what we can do is we can write them out because some people don't like seeing them in tree form. So we said our first outcome was apple with milk, or we could have apples with water, or an apple with orange juice. Okay. And then down here, we could have pretzels with milk. Got pretzels, water. Or pretzels with OJ. So we have a grand total of 1, 2, 3, 4, 5, 6 outcomes. And then our question was, going all the way back to the question, what is the probability that we will pick pretzels and orange juice? Which was our very last one we wrote. That's our only favorable outcome. As we said, probability is just favorable outcomes over possible outcomes. So the chance of picking at random pretzels and orange juice is 1 out of 6 out. Okay? So what is the chance of picking pretzels and orange juice? 1 out of 6. And that's our whole thing. So here's our sample space. So anytime it says, what's your sample space, you want something that looks like that. Okay? Or something that looks like this. Or you can put both if you're feeling fancy. But that's the idea. That's what sample space is. List of every possible outcome. And then we're halfway done. Alright, so part 2. Determine the sample space for spinning both spinners. Draw yourself 2 spinners. Everyone likes spinners. Okay. What about the 1 to 6? 1 to 6, that's your probability. That's the chance of picking pretzels and orange juice. That was the answer to the question. Oh, I never changed the title of this one. Chapter 5, Lesson 3. That saves automatically. Alright. Yes. So this time our 2 events, we have pick our number. That's our first event. And then we pick our color. Put these a bit closer together. So our first event, we want to pick one of our numbers on our spinner. So we could get a 1. Or actually, let's do this one at a time so we'll make sure we have enough space here. So if we picked 1, or if we landed on 1 on the spinner, what color could we get? So we could get 1 and red, or we could get 1 and blue, or we could get 1 and green. And then we move on. So if we don't land on 1, what other number could we land on? We could land on a 2. And if we landed on 2, the colors we could get are still red, blue, and green. So what you'll notice, no playing video games, it's note time. Calm down. Alright, so don't be downloading things. You need to save your bandwidth for YouTube videos. If we land on a 3, we could still get red, or blue, or green. So something you'll notice about sample spaces is a lot of repeating. Whatever our outcomes were for our first event, it's going to be the same thing for everything else. So if we landed on 4, we'd still have red and blue and green. That is all of our outcomes. So we could list them out. So we have 1 in red, 1 blue, 1 green, 2 in red, 2 blue, 2, I'm not your daddy. Don't call me father. Weird. 3 blue, 3 green, and 4 red. This is not a good stream to try to stay awake to. This one's probably the most boring one we're going to do. I was lied to by Geyer. Thought we were doing real compound probability. We're just making sample spaces. Sleepy face emoji. So here it is. So how many outcomes are there? There are 12 outcomes possible. Okay. And then another way you could figure out this 12, hopefully you can figure out by looking at it, is if we say how many outcomes were there for the first event, it was 4, and if we multiply that by the number of outcomes for our second event, which is how many colors there were, 3, we get 4 times 3 is 12 outcomes. And that way, if we knew that, if we knew 4 times 3 is 12, we would know that we would need to write down 12 things here. And we did. We have all 12. We did it correctly. We've done sample spaces. You are ready to learn compound probability, or compound events. Okay, that's it. You can be done now. Go on. You're free. That was fast. Nothing to it. Just a bunch of writing. Do you remember Chris Freeland? I don't know. You learned nothing. Could you write a sample space? Read my comment at the top. Did I get mad at some kids? You'd have to be more specific than that. JK, I don't get mad at kids. I'm a happy person. I could roll these. Alright, so for bonus points, if you roll 2 dice, how big would your sample space be? How many total outcomes would be possible? Bonus question. How many? This isn't gambling, so we'll call them fair number cubes. Question mark. This is an easy bonus question. The answer is not oof. The answer is a number. What is it then? Think you know what it is? That's not helpful. What's the answer? 24 is incorrect. Is it 36? That is correct. There are 36 outcomes. Because there are 6 sides on any die. 6 on the first times 6 on the second is a total of 36. Good job. All right. Let's see. Do another one. All right, let's keep the dice. I mean, fair number cube. Ha 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 ha. What else we talk? I like that one. I like this Canadian nickel. All right, what is the sample space for one fair number cube and one Canadian nickel? Or, no, I don't want sample space. That takes a bunch of writing. How many one fair number cube and one Canadian, spelled that wrong? Canadian, there, it's capitalized. Nickel, question mark? Alright, Yapper got the last one. Hopefully someone else can get this one. They don't steal all the credit. It's not 2 on both these things. Oh, yeah. No, this doesn't toss. My cube still got it. Sure. Oh, incorrect cheesesteak. Gets it right. There are 12 possible outcomes. Because again, the cube has 6. And the coin has 2, right? It can be heads or it can be tails. So 6 times 2 is 12. You did get it right. Good job. Alright, what if we went further with this one? What if we said, what is of getting a 3 on the cube and tails on the coin? So of those 12 outcomes, how many of them has a 3 on the cube and tails on the coin? That one would be a fraction. Its probability we write as fraction. What is your chance of getting a 3 and tails? Oh, Momo got it right. Good job, Momo. If we look at it, we write out our sample space. I'm going to do this kind of lazy, because I can. Let me do slightly better. Okay. So if we look at all the things that can happen, right? Get 1 in heads and tails, 2 heads and tails, 3 heads and tails, 4, so on and so on. But we want both of these things to happen. So we want to get a 3, and then after we get a 3, we also want it to land on tails, right? So only one of our outcomes is favorable, which is why the probability of getting a 3 and tails is 1 out of 12. We could change it to a percent. What's 1/12 as a percent? Your next question. What is 1/12 as a percent? Rounded to the nearest hundredths. Nearest hundredths, 2 decimal places. .8's not even a percent. .83. Still not a percent though. 83%. 1/12 is 83%? You're saying if you got one question right on a 12-question test, that's 83%? That's your grade? Come on now. You're both close, but neither of you is right yet. Top in. Bottom out. Can't say never mind after I explain to you why it's not correct. That's not how that works. 17%. Oh, so close. So this is 0. This is 8. 8 goes into 12. 96. 4. Then this is 3. Right? 4 left over. That is repeating. Right? So it is 0.083 as a decimal. So we move it over 2 places. So our final answer would be 8.33%. Yes, you have to put the percent sign if it asks for a percent. So the correct answer goes to Momo B. Momobi. Momobi. So shout outs to Momo B. I don't know who that is. Figure out who it is and tell Geyer to give that person extra credit. Alright. I'm out of time. So, good job. Have a good evening. Or whatever it is you